Hello, third graders. When we left on last week, the last lesson was lesson 2.8, part 1, and I left you with two problems that you needed to try to work out. Draw pictures to help you solve them, use some number models, write some words, whatever strategies you needed in order to help you solve the problem. Let's review those problems. So if you have it handy, go get it and have it near you so that you can see it. So the two problems that you were responsible for working on last week were these. In the directions say solve the problem, use pictures and words to show your thinking. The first problem that you needed to be working on was there are 20 children in art class. If 4 children can sit at each table, how many tables do they need? And the second problem, there are 20 children in music class. If 6 children can sit at each table, how many tables do they need? Before we look at some solutions, let's again look at the problem and think about what do we know. In number 1, what do we know? There are 20 children, and 4 children can sit at a table. So what you needed to find out was how many tables do they need? All right. And then in the second problem, what do we know? We know that there are 20 children in the class, and if 6 children can sit at a table, your task was to find out how many tables do they need. Over the next couple of slides, what I'm going to do is show you some solutions from other kids. Show you some ways that other third graders worked to solve the problem. Okay? So first we have student A. Student A solved their problem this way. Student A says that they're going to need 5 tables for number 1, and they're going to need 4 tables for number 2. Let's think about what they did. Well, they really went to town and drawing pictures, didn't they? All right, so here's the different tables at the art class. So it looks like maybe they drew one table and gave it 4 kids, another table and put 4, another table and put 4, another table and put 4, and then the last table and put 4. So let's count those people up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. So there's our 20 children, and there are 4 at each table. So how many tables do they need? They need 1, 2, 3, 4, and 5. And hopefully you got that same answer. And maybe your picture looks a little bit like this. Maybe you did it differently. That's fine. For number 2, this is how the student solved it. There are 20 children in the music class. If 6 children can sit at a table, well, this time they just drew chairs. So 1, 2, 3, 4, 5, 6 chairs at that table. 1, 2, 3, 4, 5, 6 chairs at this table. 1, 2, 3, 4, 5, 6 chairs at that table. Well, that's 18, but I need 20. So then I have 2 chairs at that table all by itself. So I'm going to have 3 full tables, plus I need another table with 2 chairs. So I'm going to need 4 tables altogether. Let's look at another solution. So here we have child B, and there, when in doubt, draw it out. How are the representations different from child A to child B? Well, child A drew pictures of tables and chairs. Child B did not. Child B drew an array. We've talked about arrays before. The child drew a circle for each child and put 4 circles in a row to show 4 children can sit at one table. So here's a table with 4 right there. Here's a table, here's a table, here's a table, and here's a table. 4 kids at each table. So we need 1, 2, 3, 4, 5 tables. Yep, same answer. Now here, there are 20 children in the music class. And if 6 children can sit at each table, how many tables do they need? Same problem, but a different representation to get the answer. This child solved the problem in a little bit interesting way. Again, he's got his tables, but we know we have 6 children. So 1, 2, 3, 4, 5, 6. Okay, so he did rows of 6 for his array. And he did 4 rows, but then he realized that, hey, this is too many. So he took some away and realized I'm still going to need the 4 tables. And another way, let's see what this child did. So this is for the second problem. There are 20 children in music class. If 6 children can sit at each table, how many tables do they need? So he or she, this person, started with a multiplication problem. Oh, there's a key. Look at this. So a square or a rectangle, square, means a person. The line between them, so this line here, represents table, and this is the rug. Okay? So what he did was he put 6 people at a table. There's 6 and 6 and 6. And then he's saying that I'm going to put those leftover people on the rug. So 3 tables plus 2 people left over, they can sit on the rug. However, that's not what the question was asking. I'm not going to put anybody on a rug. They have to sit at a table. So this little fella had some good strategies. However, he did not come up with the correct answer because he put our leftover people on the rug. And we're just going to put those leftover people on another table. So the answer is going to be 4. It's still going to be 4 tables. Okay? So what you're going to work on today is just your math journal, page 51. Good luck.